Hello, welcome to week 15, chapter 7, lesson 3, logarithmic function as inverse. At the end of this lesson, you should be able to write exponential equation in logarithmic form, and you should be able to evaluate a logarithm, and you should be able to use logarithmic scale. Now let's go to the content of the lesson. So in this week, we are going to discuss key concepts regarding logarithmic function, and then we are going to practice converting exponential equation to logarithmic form, and we also practice how to evaluate a logarithmic expression, and we are going to discuss about the graph of logarithmic function, and finally we will see how to translate a logarithmic function. As usual, at the end of each solved problem you should solve the guide equation from your textbook. Now let's go to the key concept. A logarithm base b of a positive number x satisfies the following definition. For b greater than 0 and b different from 1, the logarithm of x to the base b is equal to y if and only if b to the power of y is equal to x. Here from this definition, you can observe that logarithmic function and exponential function are inverse to each other. So if the two functions are inverse to each other, then we can easily relate their graph. From last week's lesson, when we discussed about exponential function, we saw the graph of the exponential function. So for this week, it will be easy for us to draw the graph of the logarithmic function, because if two functions are inverse to each other, then one is the exact reflection of the other across the line y is equal to x. So for example, if you want to draw the graph of the logarithmic function, what you will do, you just reflect the graph of the given exponential function across the line y is equal to x. So this is a basic concept regarding the logarithmic function. Now let's go to problem 1. In problem 1, you are asked to convert the logarithm, to convert the exponential expression to logarithmic form. What is the logarithmic form of the equation? Part A, 10 to the power of 2 equal to 100. So to convert this exponential equation to a logarithmic form, what you need to do? You need to apply the definition for a logarithm. That means if e to the power of y is equal to x, then logarithm of x to the base b is equal to y. Therefore, 10 to the power of 2 is equal to 100, means logarithm of 100 to the base 2 is equal to 2. Part B, 3 to the power of 4 is equal to 81. So, to convert this exponential to logarithm, you have to apply the definition. If e to the power of y is equal to x, then logarithm of x to the base b is equal to y. Therefore, 3 to the power of y is equal to 81 implies logarithm of 81 to the base 3 is equal to 4. So in problem 1, you exercise how to convert exponential equation to logarithmic form. Now let's go to problem 2. In problem 2, we are going to exercise evaluating logarithm. What is the value of logarithm of 32 to the base 8? So in order to evaluate this logarithm, first let this logarithm of 32 to the base 8 is equal to x. Then convert this logarithm to exponential. It will be 32 is equal to 8 to the power of x. Then write each side to the base 2. So 32 means to the power of 5 and 8 means to the power of 3. Therefore, the equation will be to the power of 5 is equal to the power of 3x. Since the two bases are equal, then the exponent will also be equal. Therefore, we'll get 5 is equal to 3x, which is a linear equation. Then solve for x by dividing each side by 3. Therefore, the value of x will be 5 over 3. This is one way that we evaluate a logarithmic expression. Now let's go to problem 3. Problem 3 is about using a logarithmic scale. In December 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. The diagram shows the magnitude of an earthquake that hit Sumatra in March 2005. The formula logarithm of I1 over I2 is equal to M1 minus M2 compares the intensity level of earthquake, where I is the intensity level determined by a seismograph, and M is the magnitude on a Richter scale. How many times more intense was the December earthquake than the March earthquake? Here you are asked to compare the intensity of the earthquake in the 2 months. That means in December and March. So to compare the magnitude of the earthquake and the intensity, there is a formula which is given by logarithm of I1 over I2 to the base 10 is equal to M1 minus M2. Here, logarithm of I1 over I2, where there is no base, means that it's understood the base is 10. Okay? Then, what else is given? The magnitude of earthquake in each month is given. So, logarithm of I1 over I2 is equal to 9.3 minus 8.7. Simplify it. Then convert this into exponential equation. So you will get I1 over I2 is equal to 10 to the power of 0.6, which is approximately 4, which means that the December earthquake was about 4 times as strong as the March. So this is one problem that relates to logarithmic scale. Now let's proceed to problem 4. Problem 4 is about graphing logarithmic function. As I said earlier, to draw the graph of logarithmic function, we are going to apply the graph of the exponential equation, function. That means, as we said, to draw the graph of the logarithmic function, we just reflect the graph of the exponential equation or a function across the line y is equal to x. So let's see problem 4. What is the graph of y is equal to logarithm of x to the base 3, and describe the domain, the range, and identify the y-intercept and the asymptote. Now, in order to draw the graph of y is equal to logarithm of x to the base 3, what is the inverse of logarithm of x to the base 3? It is y is equal to 3 to the power of x. And we know the graph of y is equal to 3 to the power of x from last week's lesson. So what we'll do, you just reflect the graph of y is equal to 3 to the power of x across the line, y is equal to x. So you will get this graph. That means the red one is y is equal to 3 to the power of x, and the blue one would be the graph of y is equal to logarithm of x to the base 3. The domain of the logarithm function will be all, as you can see, it is all positive number, and the range is all real number, and the graph of the logarithm function does not cross the y-axis. That means there is no y-intercept, and the x-intercept will be 1, and the line x is equal to 0 or the y-axis will be the vertical asymptote. This is the graph of y is equal to logarithm of x to the base 3. Now let's go to the final problem, which is about translating the logarithmic function. How does the graph of y is equal to logarithm of x minus 3 to the base 4 plus 4 relate to the parent function? The parent function for this one is logarithm of x to the base 4. As you can see, this is a translation where it moves 3 units to the right and 4 units up. Therefore, you know the graph of logarithm of x to the base 4, the parent function. Therefore, you just translated the parent function 3 units to the right and 4 units up. So you will get this graph. Okay, green one is the parent function, and the blue one is the uh, graph of logarithm of x minus 3 to the base 4 plus 4. So this is about lesson 3. We will have more discussion on the live discussion. So if you have any question, you can raise your question in the live discussion. So thank you very much. I will finish the discussion here.